Okay, hello and welcome to today's lesson. Today we'll be looking at the introduction of metrics. My name is Jay Akwedobo, and I hope you have already subscribed. But if you have not done so, I want to urge you to please subscribe to this channel so that you receive notifications whenever I upload new math video. Okay, so please like, share, and make comments on this video and any other future videos that I will be uploading. Okay, so without much ado, let's start. The first thing is we need to understand what is a matrix. A typical matrix is a rectangular array of numbers arranged in rows and columns and enclosed into a pair of braces. So that is the definition of a matrix, and mathematically we can represent a matrix in this form. So here we have an array of numbers, and these numbers are enclosed into a pair of braces, and then the name of this matrix is matrix A. Okay, so let's see the sizings of a matrix. So we say by convention, matrices are sized using the numbers of rows, which is m, by the number of columns, which is n. So in other words, if you have a matrix in this form, the size of this matrix is just simply, here is a 3 by 4 matrix, because the 3 represents the number of rows. We have 3 rows in this matrix, so that is the 3 rows. And we also have 4 columns, so this is the 4. So you will usually see the size of a matrix given by m cross n. So in this one we have matrix A, and the size of matrix A is 3 by 4. So this is a 3 by 4 matrix. Okay, so another one you can see here, this is a 3 by 3 matrix because you have 3 rows and 3 columns. So this is a 3 by 3 matrix, and that is matrix B. And you see here, this is a 4 by 2 matrix. The first number represents the number of rows, and the second number represents the number of columns. So here, matrix C is a 4 by 2 matrix because we have 4 rows and 2 columns. This is a 1 by 1 matrix because we have 1 row, 1 column. All right, so we'll look at some special matrices. Number 1, we are going to look at the square matrix. A square matrix is an m by n matrix in which m is equals to n. So for a square matrix, the number of row and the number of column must be equal. So you could have a 2 by 2 matrix, meaning you have 2 rows and 2 columns, a 3 by 3 matrix, 3 row, 3 column, 4 by 4, 5 by 5, and you name it. But the number of row is equals to the number of columns. So such a matrix is called a square matrix. And we have a vector. A vector is an m by n matrix where either m or n is equals to 1, but not both. So meaning you can either have the row as being only 1 row with several columns, or you have several rows, 1 column. Okay, so if you have any of such matrix, that matrix is considered to be a vector. So let's see an example of this. Okay, so this is a square matrix. This is a 3 by 3 square matrix because you have the number of rows equal to the number of columns. And here, matrix X is a 4 by 1 matrix. So it is considered to be a vector because they have only 1 column and several rows. And matrix Y is also a vector because it has 1 row and 3 columns. Okay, but if you have 1 row and 1 column, that is not a vector. That's a different kind of matrix that we will see shortly. So we have a scalar. A scalar is an m by n matrix where both m and n are 1. Okay, so we have a 0 matrix, an m by n matrix of zeros. It means all of the members are 0. All of the members of that matrix are or zeros. There is no other number except zero. So that is a zero matrix. Okay, so you have that. And okay, identity matrix is square m by m matrix with ones on the diagonal and zero everywhere else. Okay, so for an identity matrix, the first thing is it has to be a square matrix. That's the first condition. And the second condition is that it must contain only two kind of numbers. Those are zeros and ones. Okay, that's the second condition. And the third condition is that the ones must appear only along the diagonal of that matrix, and all other numbers are zeros. Okay, so those are the three conditions. So for example, you have here, this is a 3 by 3 matrix. It's a square matrix. It meets the first condition. And the second condition is that only zeros and ones are present as members of that matrix. Yes, of course. And you have only ones along the diagonal. Okay, the diagonal of that matrix. And all other values are zeros. So this is an identity matrix. Okay, so we are also going to be looking at transposing the matrix. Okay, matrix transpose is the M and N matrix obtained by interchanging the rows and columns of a matrix, converting it to an N by M matrix. So matrix transpose is just simply converting the column into a row in the new matrix, and then the row into a column in the new matrix. Okay, so let's see an example. Okay, so if you have here matrix X is a 4 by 1 matrix. Okay, because we have 4 rows and 1 column. So what we do for matrix X prime, which is the transpose, is that we will interchange the number of row to the number of columns. Okay, and that of the number of column to the number of row. So you have four rows and 1 column in the original matrix. So when you transpose that matrix, then you will have now 4 columns and 1 row. Okay, so the first row will become the first column, and the second row is the second column, the third row the third column, and the fourth row the fourth column. So you have to interchange them. So this is how we can transpose matrices. Okay, so let's see another example of matrix transpose. Okay, here matrix A is a 3 by 4 matrix, and when we transpose that, it becomes matrix A prime will become a 4 by 3 matrix. And how do you get that? So the first column here in matrix A will become the first row in the transpose matrix. All right, and the first row in matrix A becomes the first column in matrix in the transpose matrix. So you will do that. The second row in the original matrix will become the second column. So you just do that and you transpose it. So that becomes a transpose matrix. That's it. Thank you.